Hello everybody, today we are going to be talking about the idea of factoring a polynomial completely. This is a process that we take to make sure that every factor in our answer is as factored as much as possible. So if you would think about this in the way of numbers, it's the idea that, if you factor out 12, that's 4 times 3, but that's not completely factored because 4 can break down even more, right? So 2 times 2 times 3 would be the complete factored form of 12. So that's what we're going to be doing with our polynomials today. Sometimes this is called mixed factoring. And the reason for that is because within one problem, you will be doing possibly more than one type of factoring. Okay, so these problems will take multiple steps. So in your work, make sure you show each step so that your teacher knows where your answer came from. All right, let's look at the first example. Okay, anytime that you are doing a problem and the directions ask you to factor completely, the first thing that you want to look for is you want to always take out or divide out a GCF first. That's really important to do. A couple reasons for that is if you don't take it out at the beginning, you're going to have to take it out at the end. The reason why I like to take it out at the beginning is that way I have smaller numbers to work with, and it makes the other types of factoring easier to do. So let's look at example 1 and look for the GCF. The GCF of the numbers is going to be a 7. The GCF of the letters or the variables is going to be a B. I'm going to divide this in my head. Dividing 28 by 7 gives you 4. Taking away this B will leave you with just an A squared. Then you have a minus sign. You're going to divide 63 by 7, that's 9. Taking away the B, well, there's no variables left. Please make sure that the GCF is not disappearing. It is not magic, it is math, so it must be part of the factored form. Okay, so when we go to move on to the next step, we need to make sure that the GCF goes along with the next step and then eventually into the final answer. Okay, this is a two-term polynomial. A type of two-term polynomial that we are familiar with is the one in the form of a squared minus b squared. We call it a difference of squares or a difference of two squares. And these have a pattern of factoring into two binomials where the terms are the same but the sign in between is different. Okay? So bring down your GCF. This is a difference of two squares. Both terms are perfect squares and there's a minus sign in between. That's how we recognize those. If you would like more information on that, check out some of my other videos. Okay, so this is going to factor into two binomials like the pattern I see over here on the right. I'm going to break up the 4a squared and the 9, I like to say evenly, right? I'm not going to do 4 times 1. I'm not going to do 9 times 1. I'm going to do 2 and 2 and 3 and 3 because I want these terms to be the same. The only thing that will be different is the sign in between. So breaking up 4a squared to 2a and breaking up 9 to 3 and 3. Opposite signs in between. That rhymed a little bit. Noticing that I have factored that out completely. There are no GCFs left in either of the parentheses. That's something that you're going to hear me say with each problem, just double checking that there's nothing more we can do with the problem. My GCF that I took out at the beginning is part of my answer. So this is my final answer. If you were to multiply all three things back together, you would get back to where we started. Okay? All right, moving on to example number 2. Always take out a GCF first. Some problems will have a GCF, some problems will not have a GCF. With other problems, the only type of factoring that might happen is a GCF. So we want to do that first because that might be the only thing you can do. Plus, if I take out the GCF, I'm going to have smaller numbers. So if I take out the GCF of this problem, hopefully you already recognized it as a 3. Dividing each term by 3 gives me m squared plus 3m minus 10. Okay? Looking at what's left inside the parenthesis here, This is one of those problems that we can recognize as ax squared plus bx plus c when a equals 1. When a equals 1, it's actually very easy to factor because we can just use product and sum of these last two numbers to get us to our answer. Something in this form will factor into two binomials. So I'm going to bring down my GCF. It's going to be on the outside of my two binomials, and I'm going to start placing things into my parentheses. I know that when a equals 1, that the variable in the first term will just split up as variable times variable. Okay? For these last two terms, they need to multiply to negative 10. But when a equals 1, we also know that those two numbers need to add to our b term, which in our case is 3. So I need two numbers that have a product of 10, but a sum of 3. Yes, that would be a positive 5 and a negative 2. Now let's just check our answer really quickly. Let's make sure these two binomials give us this. M times m is m squared. 5 times negative 2 is negative 10. 5m, negative 2m gives me 3m. And that is how you can very quickly check it in your head. Okay? So then GCF as part of your answer, double check that always, and you get this as your completely factored form of the original polynomial. For the next two examples, I want you to do the first step on your own. So on these next two examples, go ahead and do the GCF part first, if there is a GCF. So click pause and try that out on your own. Okay, let's look at this example here. If we take out a GCF, you should have taken out a 3xy. Taking that out would leave you with 8xy minus 2y plus, now if you divide out a 3xy from a 3xy, it's going to cancel. It doesn't cancel out meaning it's gone forever. It cancels out because it's a 1. So that's what we call an equivalent form of 1. You must have that plus 1 there. If you don't, let's say that you didn't put that there and you close your parentheses here. There is no way that you would be able to multiply this back together and get to your original problem. When you take out a GCF from 3 terms inside the parentheses, you should have 3 terms. Continuing on with this problem before we check our GCF on the second problem, you can see that this does not follow any patterns that we notice. It's not a difference of 2 squares, it doesn't have any form that looks like this, and it is not a 4-term polynomial. So this is as factored as it can be. Again, double check that your GCF is part of your answer. Okay, next problem. You should have taken the GCF out already, but if you haven't, pause the video and do that. So looking at this problem, you should have taken out a 4x squared. Okay, remember this has 2 x's, this has 3 x's, this has 4 x's. So the most they have in common is 2. And the 4 is a number that goes into both 8, 4, and negative 24. So dividing that out, you're going to get a 2x squared. You are going to get a minus x, and you're going to get a minus 6. So this is what you are left with, okay? Now, you might say there's a bigger GCF, but there is not, because there's 2 and 6 have a common factor, but this middle term does not have any more common factors with those. So that's the biggest common factor that you have is 4x squared, okay? Now, this problem here, again, is in the form of ax squared plus bx plus c, but this time a does not equal 1. So this type of problem is a little bit more challenging to factor, okay? So when I go to factor this problem out, I have two choices. I had showed you two ways to do this problem. Some of you like to use the grouping method. Some of you still like to use the guess and check. So please take a moment, pause the video, and I would like you to try the problem with whatever method you like to do. So your goal is to factor this portion of the problem using one of these two methods. You pick what makes more sense to you. We should all get to the same answer, so it does not matter which way you do it. Okay, using guess and check or grouping, it's going to factor into two binomials. To get 2x squared, the only way that you could break that up is 2x and x. Okay? To get 6, you have a couple options. You have 6 times 1 and you have 3 times 2. Okay? I'm going to go ahead and do 3 times 2 because I want to try to keep my numbers kind of small. And if I do a 6, I'm afraid that I'm going to get like a 12, and it's by multiplying it to the 2, and I'm going to have big numbers. So you just have to pick something. So I'm going to go with 3 times 2. It seems to be more common, right? Now, when I go to plug that in here, I'm not going to do this. The reason I'm not going to do this is because in a binomial, you should not have any common factors. So this is not possible because we already took out the common factors at the beginning of the problem. That is another reason why it's important to take the GCF out at the beginning of the problem. So my option, if I'm using 3 times 2 to get 6, is going to be this. Okay? Now that has to be a negative 6. So I know that the 3 and the 2, one of them has to be negative. Which one? I don't know, so I'm going to make a guess. What if you do plus and minus? Right? If you do plus minus, it's very easy to check your answer. 2x and x is 2x squared. 3 and negative 2 is negative 6. Eyeballing this, that's 3x, that's negative 4x. You can write it down or you can do it in your head. Do you see that that gives you negative x? So that is your answer. So this is your final answer. Now, if you chose to use the, things got erased here. Let me fix that. If you chose to use the grouping method, your work is going to look different, but you will get the same answer. Remember, if your answer looks like this, if it's 4x squared and then it's x minus 2 times 2x plus 3, that is the same thing. The order in which you multiply does not matter, so the order of your parentheses does not matter, as long as the parentheses are the same. Now, if your parentheses are x plus 2 and 2x minus 3, that is not the same, right? So that's really important to understand that your parentheses should be the same, but they don't have to be in the same order, right? Also, you do not need to put a dot in between parentheses. Parentheses side by side is an indication of multiplication, okay? All right, so let's move on to the next problem here. In the next problem, we do have a GCF. The GCF in this problem is a 3. Now, if you don't recognize that 3 goes into 75, think of 3/4, right? 3/4 make 75 cents, so I know that 3 goes into 75. So dividing each of those by 3, that's a popular GCF apparently. We have 25x squared minus 10x plus 1. Now, this problem here, this is what we call a perfect square trinomial. If you remember, we did some problems that were in the form of this form, right? The x squared plus bx plus c. But it was in that form, but the first and last terms were perfect squares. Okay, the other way that I recognize that it's a perfect square trinomial, first of all, is the first and last terms are perfect squares, and the last term is a plus. It can't be a perfect square trinomial if the last term is a minus. That's not going to work. Okay, in a perfect square trinomial, both parentheses are going to be the same. So it could be like something like this or something like this, right? Which we can essentially write as a binomial to the second power. Okay, so if you can recognize those perfect square trinomials, that's great. If not, this problem, the binomial that's left inside, the trinomial that's left inside, can be factored using grouping or guess and check like we just did on this last problem here. Sorry, the problems are not numbered. Okay, so factoring this, knowing it's a perfect square trinomial, is easy to do. If you recognize it, you know that both parentheses have to be the same. So the only way to break up 25x squared is 5x and 5x. The only way to break up 1 is 1 and 1. Now, the way that I know that they're both going to be minuses and not plus, the only way that in the factored form they can both be plus is if all of the signs in the trinomial are plus. So I know that it has to be minus minus. If you write your answer like this, I would definitely accept it. Most multiple choice questions, though, will take the binomial and write it to the second power. Again, do not forget the GCF as part of your answer. Okay? Looking at the last example, in the last example, you can see that there is no common GCF amongst all four of the terms. But remember from yesterday's lesson that all four terms, when there are four terms, that you're going to use the grouping method. This is what we call a four-term polynomial. And if you need practice with this, I have another video. You can check that out on factor by grouping with four-term polynomials. Okay, so pause the video, and based off of yesterday's lesson, I'd like you to try this one on your own. Okay, so doing this one on your own, you should have grouped the first two terms together, group the second two terms together. Let me move this out of the way, put a plus sign in between. I'm going to take the GCF out of the first term. The first group should have been a 5a. Left behind, you would have a plus 2b. Bring down the plus sign. In the second grouping, I have a 3 in common, and since the first term is negative, I'm going to take out a negative GCF. So taking out a GCF of negative 3, I'm left with an a, and again, dividing this by negative 3, I'll get a plus 2b. Remember, the goal of grouping is to have a common parenthesis. If you don't, you've done something wrong. So go back and check your work. Okay. Or it's possible that it doesn't factor, but this one definitely factors. Okay. So taking out the common parenthesis, I get a plus 2b. And then your GCFs make up the second parenthesis. That's 5a minus 3. And then that is your answer. No GCF taken out at the beginning of the problem, so I don't need to worry about anything on the outside. Okay, so these are some examples of mixed factoring, the idea of factoring something completely, putting everything together that we have learned. If you're stuck on a specific method, don't forget to go back and check out those other videos. If you like this video, hit like, subscribe to the channel so you can easily find my other videos, and best of luck with your practice today.